In this video, we're going to be graphing piecewise defined functions involving linear functions. In order to graph a piecewise defined function involving linear functions, first we're going to set up a table for each piece of the function. Two, we're going to select values of x that are in the domain of each piece. Three, we're going to find the corresponding values of y and write the ordered pairs. And four, we're going to graph each piece. And note the following: use arrows if the interval includes positive or negative infinity. Use open circles if the endpoint of the domain is not included. So in number 1, we want to graph the piecewise defined function, state the domain and range in interval notation. In A, we have g of x is equal to 2x plus 3 if x is less than or equal to 0, and negative x minus 1 if x is greater than 0. So the first piece of the function we're going to look at is y is equal to 2x plus 3, and we're going to look at x values that are less than or equal to 0. And we have negative 3, negative 1, and 0 chosen for us. So we're going to have, if x is equal to negative 3, then y is equal to 2 times negative 3 plus 3, and 2 times negative 3 is negative 6, plus 3 is negative 3. So we can write the ordered pair of negative 3, negative 3. If x is equal to negative 1, then y is equal to 2 times negative 1 plus 3. And 2 times negative 1 is negative 2, plus 3 is 1. So the ordered pair negative 1, 1. And for x is equal to 0, then y is equal to 2 times 0 plus 3, and 2 times 0 is 0, and then we have plus 3, so y is equal to 3. So we have 0, 3 as the ordered pair. And now, when we look at the individual domain for 2x plus 3, if x is less than or equal to 0, so because we're or equal to, we're going to have a solid dot there because we can include 0. And now for the piece of the function negative x minus 1, we're going to look at values greater than 0. So we're going to look at the endpoint 0 first, and we're going to say y is equal to negative 0 minus 1, which is equal to negative 1. So our ordered pair is 0, negative 1. And because in the individual domain for negative x minus 1, it's just greater than, we're going to select the open circle because we're not including 0 in this piece of the function. And now we're going to look at x is equal to 1, so y is equal to negative 1 minus 1, which is negative 2. So our ordered pair is 1, negative 2. And for x is equal to 2, then y is negative 2 minus 1, which is equal to negative 3. And the ordered pair would be 2, negative 3. And now we want to graph g of x. So the first thing I'm going to do is look at the piece of the function that's 2x plus 3 and plot all the ordered pairs. So we have negative 3, negative 3. And I have negative 1, 1. And 0, 3. And because 0 can be included in 2x plus 3, we have a solid dot here. And now we're going to draw this piece of the function. And now we're going to plot the ordered pairs for the piece of the function represented by negative x minus 1. So we have 0, negative 1, and we're going to put an open circle at 0 because 0 was not part of the domain. So we're going to go to 0, negative 1, and put an open circle. And now I'm going to plot 1, negative 2, and 2, negative 3. And now I'm going to draw my line. And now we need to look at domain and range. And it's important to remember for the domain that the domain of g of x is the union of the individual domains, and our individual domains where x is less than or equal to 0 or x is greater than 0. So our domain is from negative infinity to infinity, which means that we can put any x value into the function and have the function be defined. And now for our range, we're going to look at our picture. And you can see that we have arrows going to negative infinity on both of the pieces of the function. So we're going to have negative infinity. But then the largest output, or the largest y value, is positive 3. And we included positive 3, so we're going to have 3 with the brackets. In B, we have h of x is equal to negative x minus 4 if x is less than negative 2, x if negative 2 is less than or equal to x is less than 3, and 3 if x is greater than 3. So the first piece of the function, negative x minus 4, we're going to look at values less than negative 2, and we have negative 8, negative 4, and negative 2. If x is negative 8, then y is equal to negative 8 minus 4, which is equal to 4. So our ordered pair is negative 8, 4. For x is equal to negative 4, then y is equal to negative 4 minus 4, which is equal to 0. So our ordered pair is negative 4, 0. And for negative 2, y is equal to negative 2 minus 4, which is equal to negative 2. So the ordered pair is negative 2, negative 2. If you look at the individual domain for negative x minus 4, it's if x is less than negative 2. So that means we're not including negative 2. So we're going to have an open circle at negative 2 because we're not including it as part of this equation. For y is equal to x, we're going to look at values between negative 2 and 3, and we're going to start with negative 2. If x is equal to negative 2, then y is equal to negative 2. So we have the ordered pair negative 2, negative 2. And if we look at the individual domain of x, negative 2 is included as part of the domain, so we're going to have a closed circle. If x is equal to 0, then y is equal to 0, which means our ordered pair is 0, 0. And for x is equal to 3, y is equal to 3. So then our ordered pair is 3, 3. And 3 is not part of the individual domain of x, so we're not going to include it, open circle. And for the piece of the function defined by 3, we're going to evaluate 3, 4, and 5. And regardless of what the x value is, the y value is always going to be 3. So we're going to have y is equal to 3 all the way down, which means that we have a horizontal line. So our ordered pairs are going to be 3, 3, 4, 3, and 5, 3. And at 3, which is an endpoint, we look at our individual domain, and 3 is not included, so we're going to have an open circle. And now we're going to graph each piece of the function one at a time. So for negative x minus 4, I'm going to plot my ordered pairs, negative 8, 4 first. And now we're going to plot negative 4, 0. And then we're going to plot negative 2, negative 2, and we're going to put an open circle because it's not part of this equation. X is equal to negative 2 is not defined here. And now we're going to draw our line. And now for the piece of the function represented by y is equal to x from negative 2 to 3, we're going to start with plotting our points, and at negative 2, negative 2, we're going to have a closed circle, so we're going to fill in this open circle that we currently had, and now we're going to plot our other points, 0, 0, and at 3, 3, we're going to have an open circle. And now we're going to draw a line between those two dots. And now the last piece of this function that we need to draw in is the horizontal line at y is equal to 3 from 3, but not including 3, to infinity. So we have this horizontal line from 3 to infinity at y is equal to 3, and not including that endpoint. So now we need to look at domain and range. And if we look at our individual domains, we can see that x is defined if x is less than negative 2, and then we have less than or equal to negative 2 as our second individual domain, all the way to 3, but not including 3, and then if x is greater than 3. So the only number not defined is x is equal to 3. So that's the only number that we need to exclude in our domain. So we're going to have from negative infinity to 3, union 3 to infinity. And then as far as our range, the smallest value that y can take is negative 2, and we're going to include it, and that's at this point right here where the v comes together. So we have negative 2, and then The piece of the function on the left has an arrow going up forever, so the range can be infinity. And that's all for this video on graphing piecewise defined functions involving linear functions.